Welcome back to the Bitkom Quantum Summit 2022. I hope you could charge some energy during this short break. My name is Natalia Stolarchuk and I'm a policy officer at Bitkom for future computing and microelectronics. We do have a very interesting program ahead for this afternoon, and we would like to start with a subject that was already mentioned several times yesterday and today, and to dig a little bit deeper what exactly we understand onto this topic. And I'm speaking about ecosystem. And for this, I would like to invite my first speaker, Professor Dr. Tommaso Calarco from the Forschungszentrum Jülich. Professor Calarco is a director of the Institute of Quantum Control and professor of quantum information at the Institute of Theoretical Physics at the University of Cologne. 6 years ago, he authored a quantum manifesto which initiated the European Commission's Quantum Flagship initiative. And in his talk, he will tell us about the way from the quantum flagship to the European ecosystem. Welcome, Professor Calarco. Nice to have you here.
Thank you very much. It is a pleasure to be here, especially in this specific discussion about quantum ecosystem. And indeed, so let me now share my slides. And I would like to tell you a little bit how we move on from what we started a few years ago with the flagship towards a broader initiative, which I may call a quantum fleet or perhaps a quantum ecosystem at European level. So this is what I would like in the next 15 minutes to tell you. The starting point is the research agenda of our quantum flagship. So since the beginning, we have been focusing on several application areas, which are quantum communication, quantum computing, quantum simulation, quantum sensing and metrology, but also on a very important area, which is the basis for all of this, which is the aspect of basic science, which is something we regard as a very important scientific resource. And together with technological resources, which are our cross-cutting activities in engineering and control to enable really the transition from the lab to outside, to the real world of software and theory, to really bring forward new concepts, new algorithms, for instance, for quantum computing, as well as for education and training in terms of providing new workforce, people who can really bring both research and innovation forward in academia and in industry. So with all these components, this is where we started our flagship. And this is in the framework program for research and innovation Horizon Europe. So this is the research part. What is the role of the flagship in the ecosystem? It is to provide technology towards implementation. And here in the program Digital Europe, which is an additional new program of the European Commission, for digital society, we are deploying these ideas and technologies into infrastructure. The EuroQCI, the European Quantum Communication Infrastructure, and the EuroQCS, the European Quantum Computing and Simulation Infrastructure, in the context of the joint undertaking for high-performance computing, EuroHPC. So this is a little bit the context of what I'm going to detail a little bit in the next few minutes. So, of course, probably I don't have to tell a lot about quantum computing, in which you have just, instead of classical bits, you have quantum bits, and you can get superposition and explore paths of different possibilities in a computational process. And this is really just one example, which is fictional, as we know at the moment, because we do not yet have, let's say, a quantum algorithm which gives a speed up for a search in a labyrinth. But we are, developing the first implementation in the so-called NISQ era, the noisy intermediate size quantum computers, towards really useful applications. And of course, we know that these machines start being commercial. This is a picture of the IBM system Q1, which was commercialized since a couple of years. And now there is also the very prominent result from Google, which in the meantime, it has been discussed. In the beginning, the claim was that with 53 qubits in 2.5 minutes, they managed to solve a problem which the fastest supercomputer on Earth would take 10,000 years to solve. In the meantime, there have been, development of algorithms which allows to solve this problem, on a definitely shorter time scale, still definitely longer than the quantum chip. But there have been other demonstrations, for instance, in China with a larger number of qubits, in which the gap between the performance of the quantum processor and of a classical supercomputer is diverging more and more. This was essentially a milestone in terms of the first time in which we have been seeing that quantum computing is practically possible. And now, we, from the point of view of our European ecosystem, we may start worrying because we see some examples which come from the US. But I can happily report, actually, I'm now in Paris. Tomorrow we are going to have the final review meeting of the ramp-up phase of the flagship. In the first 3 years of our quantum flagship, we managed to stimulate very many startups in different fields, including in quantum computing. And now, since I am sitting in Paris, actually, I would like to mention the company, the French company Pascal. Of course, there are also other startups in quantum computing. This one is for quantum simulation with neutral atoms, Rydberg atoms. There is a startup for quantum computing with ions, Alpine Quantum Technologies. In Austria, there is another in Finland, IQM, for quantum computing with superconducting qubits, and there are others which are, nascent. I show this because this is really something that we plan to adopt into our first pilot project of the quantum computing and simulation infrastructure. The idea here is that to really go beyond, to break the threshold, not only in terms of computational power for any problem, maybe some just academic problem like Google developed of very deep academic interest, but not of practical use. Maybe we would like to use a quantum processor as a coprocessor to a supercomputer, really to go beyond what is feasible with normal supercomputers. So the idea is to start by, locating some quantum simulators. In this case, the first pilot is with quantum simulator from this company that I mentioned, which will be located in Paris, France, and in Jülich, Germany, in order to provide access to a broad community of users to develop new applications, to also as a test bed for ideas, in future also as a test bed for other platforms, other kinds of processors, in order really to develop, validate, and benchmark also algorithms and application for really the benefit from the academic field going into really what can benefit the industry. So this was for quantum computing. Now a couple words on quantum communication. Again, here you are aware that if you use single photons for encoding, actually not directly for encoding information, but for creating cryptographic keys which cannot be eavesdropped because of the law of quantum mechanics, well, you can establish secure communication channels. And we also know, again, from outside of Europe, for instance in China, that a couple of years ago, first deployment of a sequence of links between Beijing and Shanghai of quantum communication, quantum key distribution segments has been implemented, not only on the terrestrial side, but also there has been implementation with a quantum satellite. Here you see a picture of the satellite. And so what we want to do is once again to say, okay, what is Europe doing? How can we really, be still on the front edge, on the leading edge of these developments? And in fact, since a couple of years, we have a joint memorandum of understanding which has been signed by 27 EU member states, a common declaration for a future quantum communication infrastructure, which is going to encompass, again, both terrestrial and space channels, in order to be a backbone infrastructure for the future quantum internet connecting via secure quantum channels quantum computers. For instance, again, in terms of ecosystem, in terms of the possibility for our companies to test software on and to really develop their own programs in a secure way, in such a way that there can be no leak of information about what is being developed, but in a completely proprietary way. And it is important, again, for our industry. I'm sure that our colleague Thierry Botter, who I see just already in the background from the European Quantum Industry Consortium, will also add to that perspective. It is very important that this is happening at a European dimension. So actually on this, I can happily report that there exist in several member states companies which also sell new startups and more established companies which are selling quantum communication devices. And here I had the honor to present at the G20 meeting of the Ministers of Innovation and Research last summer in Italy, the first demonstration worldwide of a quantum communication channel connecting 3 different states. Of course, this was easy because it was in Trieste, which is in Italy close to Slovenia and Croatia. So it was a trilateral Italy, Slovenia and Croatia. And this was done, in this case, with this particular startup QTI from Italy, just once again to show that really we have a lot of new enterprises, bubbling up and developing this and commercializing this kind of devices all across Europe. So essentially, we started. So here is a picture which I showed in our kickoff meeting in 2018 for the flagship. The idea that we have not only the framework program here of the European Commission Horizon Europe, which is really connecting to the science part and to the strategic research agenda for all these sort of moon landings, these achievements that we wanted to provide in terms of technology for further applications, but also we have, for instance, the space dimension and the space program of the European Union, which connects both to the quantum communication side, but also to the sensing side, and to the, for instance, in terms of time sensing and clocks for more precise satellite navigation, as well as, of course, the aspect of infrastructure in terms of computing under Digital Europe, which I mentioned before, in terms of high-performance computing, but also cybersecurity, connecting to the other important, moon landings that we have in the flagship, as well as with the dimension, which I also mentioned before, of education, which under digital skills in Digital Europe is being ramped up in order to provide, fresh skills for this new market and these new developments. Of course, the member states are a very important player in Europe at the level of building this also at national level, not just at European level, both with Quantera, which is a consortium of national funding agencies, but also with, for instance, Euramet, which is the Association of National Metrology Institutions in Europe, as well as with the European Space Agency, of course, which connects obviously to the space priority. And, moving forward, we have the dimension of international cooperation. There was a meeting at the White House this week, end of last week, to discuss, in a multilateral dimension. There is the Trade and Technology Council dialogue between the EU and the US, and so we are bringing forward. There is already a call in the flagship together for cooperation together with Canada, discussions with Japan and other countries. So this is what we envisioned a few years ago, and have we done that? Well, actually, where we are now is indeed, in the meantime, we have several member state programs which made together with the stronger investments from the European Commission, made the whole volume of investment grow from the envisioned 1 billion a couple of years ago to now 7 billion and counting, more than 2 invested by the European Commission, and the rest, more than 5, invested by member states. But of course, this needs to be complemented with additional investment on the side of really, venture capital stimulating the growth of those companies, which can then provide, hardware for the infrastructure, both the quantum computing infrastructure or QCS and the quantum communication infrastructure or QCI, which together with Quantera, as well as this ERANET, which I mentioned before, as well as with the Quantum Industry Consortium, which we created in the meantime and is going to present in a moment, are going to, create this ecosystem going, as you see here, really from the more fundamental side of research in Horizon Europe, from the European Research Council and the Quantum Flagship, providing, supplying technology to applications, and going through the development of digital skills in the Digital Europe program towards really these infrastructures that we are creating, but also we are developing now this Quantum Technology Fund, as you see here, with a sort of joint venture of the European Investment Bank, the European Innovation Fund, and the European Innovation Council, which are going to put together a critical mass of public funding and investment, really, in terms of taking stakes within the companies which we are going to develop in the next future. So here is my last slide, because the 15 minutes of this presentation are over, in which really this is a slide which I took from the European Commission, showing the timeline which we envision. Now the ramp-up phase of the flagship has been concluded. We have tomorrow here in Paris the final review meeting. The digital program, the Digital Europe program, has also started. We have the first quantum simulator pilot starting. There is now the call open for the first generation quantum computing, and there will be a second generation call. And now we are going towards the technology implementation, including on the quantum communication side, this infrastructure. And this will be accompanied by pilot lines calls in order to enhance production capabilities for the European science and industry, and supported for more and more startups and spin-offs from these projects in order to reach the goal around the end of this decade of a truly European quantum ecosystem. So thank you very much for your attention. Now I will stop sharing and I'm happy to take any questions.
Thank you very much, Professor Calarco, for interesting insights and updates about the quantum flagship. I have one maybe short question for you, and then maybe we can continue discussion in the scope of the podium panel discussion afterwards. So where do you see, you mentioned shortly the US and China's developments in China regarding quantum computing. Where do you see the main differences of the European ecosystem and, in your opinion, as those advantages or rather challenges that we have to, in Europe, cope with?
I would say the main challenge we have is perhaps on the industry side. That was formulated by the head of the Google Quantum Artificial Intelligence Lab, Hartmut Neven, when I went to him a few years ago to ask on behalf of the European Commission, how can we stimulate a comparable level of strong engagement from the industry? He said, you cannot, because you do not sit on a pile of cash. And indeed, this is true in the sense that the large profit margins that the US made from actually European invention, the World Wide Web, which was developed at CERN, make such big companies in a position, they put them in a position to invest very large amounts of money. We do not see so large margins which would enable our industry to, it's not like our industry is not visionary enough, but somehow the cash is not there in a sense. So this is the challenge we have. The big advantage we have is really a more integrated ecosystem in which we see, I would say, a strong integration of the industry, the private undertaking, with the science, of course, but with the public hand in order to really bridge the valley of death. This is a sort of, I would say, a unique advantage and strength which we have here in Europe. If I compare also to China, which you also asked, there is not really a significant industry investment, but there is an enormous investment from the public hand. Here in Europe, we are combining all these threads and really, creating out of all of that a unified ecosystem. I think this is a very big strength and a unique point that we have here in this continent.
Thank you very much. Again, it was a very interesting presentation, and we will meet Professor Calarco later in the podium discussion together with other participants, and we will dig deeper into the subject of ecosystems.